Okay, so to set up our theory section for the lab here, we are going to make a number of calculations, 50 calculations in fact, looking at how the pH of this buffer system is going to change as we add strong base. So the idea in this particular example is that I'm starting with nitrous acid. I am taking 0.1 moles of nitrous acid and dissolving it in 0.2 liters to get a 0.5 molar solution. The Ka is 4 times 10 to the negative fourth, which gives us a pKa of 3.40. We're going to titrate that with a strong base, sodium hydroxide, concentration 2 molar sodium hydroxide, so that each milliliter of sodium hydroxide has 0.0002 moles of the sodium hydroxide. So that's the kind of data I need to kind of predetermine before I can start to generate my numbers here. So when I start off, I haven't added any base. So I have the 0.1 molar nitrous acid that I started with and no NO2 minus. That means that I can't use Henderson-Hasselbalch here to calculate the pH. I need to use an ice table. And you can do that by hand later on. But as soon as we add just 1 milliliter, so this is base added measured in milliliters of the NaOH, then we're going to start to use our buffer. So the NaOH is going to be a base and accept protons from the HNO2 from the acid, which means that we're going to lose a little bit of acid and make a little bit of NO2 minus. Specifically, we're going to take the previous amount of acid we have and we're going to subtract 0.002 moles, since that's the amount of strong base in each milliliter that we add. Likewise, we're going to take the amount of NO2 minus that we had previously. So for me, that is the value in cell H3, and we're going to add 0.002 moles. All right? And then now we can use the Henderson-Hasselbalch equation to determine the pH here. We know that our pH is equal to our pKa, which is just 3.40, plus the log of base over acid. Base over acid. And then in Excel, we have to explicitly tell it that we want the base 10 log. So this formula that I'm using here is just my Henderson-Hasselbalch equation, where I'm confirming that it's the base 10 log. And you're going to have to do something like this in your lab. It tells us that the pH of this buffer at this point ends up being 1.7. All right? When we add another milliliter of base, so we're going to take the previous 1 milliliter and add 1 to it, that's going to slightly decrease the amount of acid, and we can just copy our previous formula down to this cell and slightly increase the amount of base. And again, we can just copy the previous formula down to this cell. Using the same Henderson-Hasselbalch equation, we can calculate that the pH has now gone up to 2.01. And obviously there's too many sig figs there. We'll deal with that later. But at this point, all our formulas are ready to go. And by copying what we have, we can calculate the new pH after every milliliter of base added. In total, we need to add 50 mils of the base before we fully get rid of our original amount of acid and reach the second equivalence point. So after we add 50, we now have 0 left of this. We have 1.0 molar NO2 minus, which means that we have to use an ice table to calculate the pH at this point. And again, you can do that by hand. But the data that we now have are enough for us to create a nice looking titration curve. So I'm going to take these data just from 1 to 49, not including the parts where I haven't yet used my ice table, and these data that go with it, and I'm going to insert a scatter plot. So I'm going to insert chart and pick the scatter plot. And you can see that we get a very nice looking titration curve right here that shows me how the pH is changing as I add more and more and more of the strong base, the NaOH, to the acid. So I can call this something appropriate, like titration of nitrous acid. I can label all my axes. So if I want to add some axis labels here, then I can call this the pH, because that's what it is. And I can call this the volume of NaOH added. And and then I'm pretty good to go. Now this is a much simpler situation than you guys have in your lab, but I recommend trying and making sure you can do this first, and then we can move on to the more complicated situation tomorrow once you've got a good understanding of Excel. Let's give that a look, and I will talk to you later.